What if the next global health threat isn't something new, but something ancient, frozen in time? As global temperatures rise, massive layers of ice and frozen ground are beginning to melt, releasing more than just water. Hidden within the Arctic permafrost are viruses and bacteria, some of which haven't seen the light of day in tens of thousands of years. And the question is, are we ready for what's coming? Permafrost is a type of ground that remains frozen for at least 2 consecutive years, though in many places it has stayed frozen for millennia. It exists in regions with consistently cold temperatures like the Arctic, parts of Siberia, Canada, Alaska, and Greenland, and even in some alpine areas of Europe and Asia. Depending on the location, permafrost can be just a few centimeters thick or extend more than 1,500 meters below the surface. But permafrost is much more than just frozen soil. It's a vast and complex environment made up of soil, rock, sand, and large quantities of ice. Trapped within this frozen matrix are ancient remains of vegetation and animal life, many dating back to the Ice Age. These remnants never decomposed fully because the freezing temperatures essentially paused the natural decay process. Over time, layers of ice and sediment stacked on top of each other, sealing away organic material in a deep freeze. This also includes microorganisms like bacteria and viruses, some of which may have been responsible for deadly infections in the past. Many of these microbes are still viable today, locked in a kind of suspended animation. Above the frozen ground lies the active layer, a thinner zone that freezes and thaws with the seasons. In summer, it softens just enough to allow mosses, grasses, and shrubs to grow, creating tundra landscapes. In winter, it hardens again. This cycle of freeze and thaw forms distinctive features like ice wedges, underground veins of ice that grow and crack in beautiful polygonal patterns. Most of the world's existing permafrost formed during or after the last ice age over 10,000 years ago. Today, it's estimated that permafrost covers about 25% of the land in the Northern Hemisphere. It plays a critical role in stabilizing ecosystems, preserving ancient history, and keeping enormous amounts of carbon locked away. But as the planet warms, this ancient freezer is starting to break open, and what lies inside could change everything. Here's where things get chilling, literally. With rising global temperatures, the permafrost is starting to thaw, and what's emerging is more than just melting ice. Scientists have discovered ancient viruses, some dating back 15,000 years, completely preserved, and in some cases, still active. During a recent 389-day expedition to the North Pole, researchers uncovered bacteria and viruses that had never been documented before. These ancient microbes may have once infected animals long extinct, but now they're being exposed to a world that has no immunity to them. We often think of viruses as modern threats, but they've always been part of Earth's history, infecting animals, humans, and even plants. Permafrost has effectively acted as a time capsule, preserving not only fossils and organic matter, but entire microbial ecosystems. Some of these microbes are believed to have been responsible for past pandemics or deadly outbreaks, and science has little understanding of how they might behave in today's environment. Worse, the rapid pace of permafrost thawing due to climate change increases the chance that these once dormant threats could enter modern ecosystems before we even identify or understand them. It's not science fiction. This is already happening. As the permafrost thaws, something much bigger is happening, something that impacts the entire planet. Organic matter that's been frozen for millennia begins to decompose, and as it does, it releases large quantities of carbon dioxide and methane into the atmosphere. These two gases are among the most potent contributors to the greenhouse effect. Methane, in particular, traps heat far more effectively than carbon dioxide. When released in large volumes, they accelerate global warming, which in turn causes even more permafrost to thaw. This is known as the permafrost carbon feedback loop. This cycle is extremely dangerous because it's self-reinforcing and potentially unstoppable within human timescales. Scientists estimate that permafrost holds nearly twice as much carbon as is currently found in the Earth's atmosphere. If even a fraction of that is released, it could negate decades of progress in reducing emissions and severely worsen the climate crisis. Additionally, the melting active layer makes the ground soggy and unstable. As ice that once held soil together disappears, the Earth can collapse or shift, destroying habitats, flooding low-lying areas, and displacing both wildlife and human communities. Thawing permafrost doesn't just pose abstract long-term risks, it's already creating very real, very expensive problems. In cities built on permafrost, buildings are beginning to tilt and sink, roads are cracking apart, and entire neighborhoods are facing forced relocation. Pipelines and communication lines embedded in the ground are bending or breaking, leading to costly repairs and environmental hazards. In mountainous regions, permafrost acts as a kind of glue, holding steep slopes together. When it melts, it increases the risk of landslides and rockfalls, which can devastate entire communities. Along Arctic coastlines, permafrost erosion combined with rising sea levels and stronger storms is rapidly wearing away the land, sometimes swallowing homes and infrastructure. And then there's the risk of explosive gas release. In Siberia, mysterious craters have appeared where methane built up beneath thawing ground and exploded to the surface. These dramatic eruptions are still being studied, but they serve as a vivid reminder of the volatile nature of a warming Arctic. Meanwhile, another less visible risk comes from the global trade in prehistoric animal remains. Fossil collectors sometimes sell ancient bones, tusks, and tissue found in the thawing tundra, but those remains could carry dormant microbes. Without proper decontamination, these materials might bring ancient pathogens into modern cities and homes. You might be wondering, can viruses really survive frozen for thousands of years? The answer is yes, and they don't just survive. In some cases, they're fully capable of becoming active again. Cryopreservation is a real phenomenon. Certain microorganisms are able to enter a kind of suspended state where their internal processes nearly stop, allowing them to survive in extreme conditions for unimaginable periods. When conditions become favorable again, like during thawing, they reawaken and resume activity. That's exactly what happened in 2016 in Siberia. A heat wave thawed a layer of permafrost, releasing spores of anthrax from an infected reindeer carcass buried decades earlier. The result: dozens of new infections, one child's death, and the forced culling of thousands of reindeer to prevent further spread. Scientists worry that other, even more dangerous pathogens could be hiding in the permafrost. Some viruses discovered recently are completely new to science, and we have no idea what kind of impact they could have if reintroduced into the environment. The fear isn't just about ancient diseases, but about unfamiliar ones our immune systems and medical tools may be unprepared for. The melting permafrost isn't just a climate issue, it's a biological time bomb. From ancient pathogens to environmental destruction, it's a threat hiding in plain sight. As the ground warms, what else will awaken from the ice? If you found this topic eye-opening, give this video a thumbs up, leave your thoughts in the comments, and subscribe for more fascinating and sometimes chilling facts from around the world. And remember, some mysteries are buried deep, literally. See you in the next one.